If a snowball melts so that its surface area decreases at a rate of 1 centimeter squared per minute, find the rate at which the radius decreases when the diameter is 10 centimeters. Okay. So I'm going to draw my snowball, which is a sphere. So now we're into 3D. Then I've got my radius. So my equation, we're dealing with surface area, so I need to use the surface area, okay? And even if you weren't sure, if you look at your units, since it's centimeters squared, that tells us we're dealing with area. So the surface area formula for a sphere is 4 pi r squared. So then my derivative, I don't have to do product rule because pi is not a variable, so all I have is an r. So the derivative of a, dA dt, do your power rule here. So 4 times 2 is 8. So 8 pi r to the first dr dt. So we've got our radius, which is 5 centimeters, half the diameter. dA dt, they tell us the surface area is decreasing, so that means this is negative. So that'll be negative 1 centimeter squared per minute. Find the rate at which the radius decreases, so that's our dr dt, that's what we're looking for. So I can take all of this, plug it into the derivative, and solve for dr dt. So I have negative 1 equals 8 pi times r dr dt. So that'll give me negative 1 equals 40 pi dr dt. Divide by 40 pi, and you'll get negative 1 over 40 pi. So you can either leave it like this or type it in the calculator. And since you're dividing by two things, use the fraction. So that'll be negative 1 over 40 pi. And that'll give us about negative 0.008. In our units, it's a rate, okay, but it's the radius, so it's not squared. So it's just regular centimeters per minute. Okay. So either one of these would be fine for your answer. So number 4, the volume of a cylinder with a radius of 5 inches is increasing at a rate of 3 inches cubed per minute. How fast is the height changing? Okay, so they tell us we're dealing with volume, okay, but even if they didn't, if you look at your unit, since it's cubed, that's what we use for volume. So I'm going to draw a picture of my cylinder. Okay, so the cylinder deals with the height and the radius. But on this one, the radius is 5 inches. It never changes. So this number goes into our picture and goes into the equation. Okay, it doesn't come after the word when. So my equation for the volume of a cylinder is going to be pi r squared, so that's 5 squared, times h. Okay, so this is pi r squared times h, but I was able to plug in r, and then I'm going to go ahead and square that 5 and make it 25h. Okay, and this is what I'll take the derivative of. So the derivative of v will just be dv dt. This is just a coefficient, so the derivative of h is just 1. So we're just left with that 25 pi, but then I took the derivative of h, so dh dt. Okay, so I don't have any regular variables left in this one. All I have are the two rates. So I have my dv dt and my dh dt. Okay, well, the 3 inches cubed, that's for the volume. Okay, it's increasing. So it's positive, so that'll be 3 inches cubed per minute. We're looking for dH dt. Just plug this into here and solve. So we'll have 3 equals 25 pi times dH dt. So divide by 25 pi, and you're going to get 3 over 25 pi. That doesn't reduce, so you can just leave it like this, or divide it on the calculator. And you will get about 0.038. And our units, this is a rate, so it's going to be inches per minute. Okay, no exponent on the inches because we're dealing with the height, which is just a regular length. Okay, so anytime you're dealing with the area, it'll always be cubed. Anytime you're dealing with the area, it'll always be squared. Any other rate will just be regular. For the next one, the surface area of a cube is decreasing at a rate of 3 inches squared per minute. So I know this is going to be negative. What is the length of the edge of the cube when the edge is decreasing? So also negative at a rate of 1 inch per minute. So I'm going to sketch my cube. Okay, so these are my side lengths, which is just the same thing as the edge. We're dealing with surface area. So the equation I should be using is the area equation. So that's going to be 6s squared. Then the derivative of a is dA dt equals, this will be 12s ds dt. So in my derivative, I've got an s, I've got a dA dt, and I've got a ds dt. So they tell us the surface area is decreasing, so that'll be my dA dt. We're looking for the length of the edge, so that's the side length, when the edge is decreasing at a rate of -1 inches per minute. So we have -3 equals 12 times, I don't know what s is, ds dt is -1. So that'll be -3 equals -12s. So s is just going to be 1/4 or 0.25. And this would just be inches because it's a length. It's not a rate, so it's not inches per minute. It's just the length of this side. A spherical balloon is deflating at a rate of 0.45 cubic feet per minute. Okay, so I know my rate is negative. Okay, and since it's cubic feet, that means feet cubed per minute. That tells me I'm dealing with volume here. Find the rate of change of the radius when the radius is 2 feet. Okay, so I'm going to draw my sphere. Okay, the only measurement we have here is the radius, but I don't put the number in the picture because it comes after the word when. So my equation, we're going to do the volume equation because that's what we're dealing with. That'll be 4/3 pi r cubed. Then my derivative, that's dV dt. 4/3 times 3 is just 4. And then a dr dt. Okay. So we need to know what the radius is, dV dt, and dr dt. So the radius is 2 feet. It's deflating, so that would be negative. This is the rate for the volume because it's cubic feet. And we're looking for the rate of change of the radius. So that'll be -4.5 equals 4 pi times 2 squared dr dt. So 2 squared is 4, times 4 is 16. So that'll be negative 4.5 times 16 pi. Then just divide by the 16 pi. And you don't want to leave a fraction in a decimal. So if you're going to leave this in terms of pi, you would do 4.5 divided by 16, change it to a fraction, and leave that pi on the bottom. So you will get dr dt equals negative 9 over 32 pi, or you can type that in on the calculator. And put the decimal answer. So that would be 0.090. Negative. Okay, and this is the rate for the radius. So that's just regular feet per minute.